move on to the next part of problem 1 that perform the forward and backward path calculations. And with that, we try to define the early event time and late event time for each single node on the path on the the network. And in this case, the what is early event time and late event time EI and LI that in the slide it defined. So early event time of node I or event I, the earliest time an activity leaving that node may begin, and late event time of node I or event I is the latest time an activity entering that node can finish. So with that, we can go back to here to just go ahead to define the node, and it's always good to start from the left to right and in the order. So 1 first, and then you can 2, 3, 4, 5, 6. Basically, you can uniquely define the node or the event. And then we want to try to find out the early event time EI and late event time. How? The first, we use the forward pass. And to find the early event time, we use forward pass. And that is EJ. EJ, that is the early event time of the end node, equal to the maximum of the early event time of the start node, the beginning node, plus the duration of the activity connecting between event I and event J, that we call it Dij. And that here forward, as you can see, forward is the addition and get maximum. So how can I do that here? So let's go forward, and go from left to right, and addition and maximum. Always we start at 0 at the first node, and then we need to fill out the duration for each activity. In this case, we have activity A, duration there given in the problem 2, B 6, 3, C, activity C. We have 3 days, activity 1 days, activity E 6 days, F 3 days, and G 2 days. So with that one here, we can do forward, addition, and maximum. So how can we get? So start at 0. Start at 0 for the start node, plus addition, duration A, as you can see, connect between node 1 and node 2. So 0 plus 2 equal 2. And then go to B, from 2 to 3, 2 plus 6 equal 8. For event 4 or node 4, so we have 2 errors come in, so we have to get the maximum in this case. So if we go from node 2 to node 4, so it go through activity C, so you have 2 plus 3, it equal to 5. Activity C equal to 3, so 5. And in this case, I suggest you to put a phantom number in there, because we have another path that from 3 to 4. So node 3 to node 4, we go through activity D, which is 1 days. So you have 3, node 3, we have the early event time for node 3, 8, plus 1, the duration of D, so we have 9. 9. And then you get the maximum, 5 and 9, so that will be here, addition get maximum 9. And then you will go to node 5. There is 2 paths go to node 5. We have 3 to 5 and 4 to 5. So you do separately 3 to 5. So 8 plus 6 is equal to 14. So put a phantom there, 14. And then node 4 to 5, we have 9, early event time for 4, plus duration F, 3. So it will be 12. And forward, maximum, 14 and 12. So you have 14. And when that 14 plus 2 node 6, so 14 plus 2 for duration of G, so we have 16. And that is forward. And with that, we can know the project duration is 16 days. Now go backward. Backward is to find the late event time. So it will be the beginner node, the late event time of beginner node equal to the late event time of the end node minus the duration and get the minimum. So you see the forward pass, addition, maximum, backward pass, subtraction, and minimum, and backward go from right to left. So here, backward, right to left. So what I do, I will start from node 6, the last node in here. So how can we do? We move from the 16 days from the early event time of that node, go to the late event time of the last node, so 16. If you have another node, you will do the same, get the maximum early event time of all of the last node, and then in this case 16, move on the late event time on the end node with the same 16 days. So in this case we have 16, then you go back will be subtraction and minimum. So 16 subtract duration of G2, so you will have 14. And now 14 for go through 5 to 4, so you have 14 minus F3, so you will have that will be only one arrow go out of event 4 or node 4, so you can do that. 14 plus 3 equal 11, so we can write out that 11 here. Now go to 3. We have two paths backward, go to 3. 5 go through E and 3, and then we have node 5. Of course, node 4 go to activity D and go to node 3. So let's go 5 to 3 through activity E. So you have 14, that is the late event time of 5, minus duration of activity E 6. 14 minus 6, it will be 8, because 2 node, I have to put a phantom number there. And then 4 to 3 go through activity D, so we have 11 minus 1, it will be 10. Phantom there. And go back, minimum, so you get minimum of 8 and 10, so it will be 8. Do the same for activity 2, 3 to 2 go through B, so 8 minus 6, so you get 2. And then you have 11, 4 to 2 minus 3, 11 minus 3, it will be 8. And that minimum 2 and 8, so you get 2. And only one path, go back to node 2 to 1, so you get 2 minus 2, it will be 0. And that's good. When you do correctly, the end node and the begin node have to be the same early event time and late event time. So why we need to do this? We need to find out how long will it take to do this project and what are the critical activities. What is the critical path? And it can be more than one critical path. So how we define the critical path? So critical path is through the node or events with the early event time equal to the late event time. So let's go back to here, see which part have that. So you see the node number 1, 0, 0, late or early event time the same. Node number 2, the same. 3, the same. 5, the same. 6, the same. So with that, I can say the critical path is go through activity A and then go through activity B, because those nodes have the same late event time and early event time. Not 3, not go through 4 at the critical path, because 4 you see the late and early event time are not the same, 9 and 11. So it will go through E, 3 to 5, and of course that will be 5 to 6 that go through activity G. So that is the critical path. So what I can say about this, we can see that project duration is 16 days. So it needs 16 days to complete. To complete that within 16 days, you don't delay on the critical activities. And those, what are the critical activities? go through the critical path. So you can have critical activity that it will be A, B, E, and G. And we also say that critical path is go through A and then sequence B and then E and G. And to manage this project, we need to make sure that we don't delay on those critical activity. Otherwise, the project will be delayed from 16 days. It can be extended further. So that same concept you can apply in problem 2, and I suggest that you will practice before you watch the video for the problem 2. And what in face-to-face class I have sent you on board to work on this problem.